I'm doing my system configuration. So you can see here, HVAKR has automatically created a single line diagram for me showing my systems and all the zones within those systems broken out by floor. I can actually jump ahead to my load summary and I can start assessing my different systems and zones even before I do my system configuration. And what I'm going to find here is the top half of this summary is a breakdown of all the load components in your system. So on the left hand side you have total space sensible and your system sensible and latent components. So this total load is really the all-inclusive number for my loads at the peak of this system, which peaks in August at 1500 hours. I can scroll down and see my heating, 83,000 BTUs total heating in this system here. But to really get accurate information about the supply airflow and my central coil data for my systems and my zones, I need to do my configuration. The first thing I'll note with this configuration is this is designed to define the air side processes that are happening in your system. So it's shown as this VRF, which because this is VRF system, we're thinking this is a condensing unit on the roof. It's going to be piped to all these zones. But what this is really meant to designate is the air side delivery system so that we can do the proper psychrometrics at the coil for each of these zones. You can contract these if you want to clear up some space here. And you might look at something closer to something like that. So I'm going to go ahead and do that because that is a lot of zones. Okay, now I have more of a concise view of what's going on here. I'm going to start with my main systems. So if I click on this, it's going to open up this dialog, this schematic, where I can define my central unit. Now in reality, this central unit is a condensing unit, air-cooled condenser, and it's going to be piped to the systems. That said, one thing we need to account for here is the outside air being distributed to these zones. So maybe it'll help if I define the zones first. That's what I'm calling these terminal units. So I can group select these like this. Scroll here on the list and I can see all the ones that have been selected. And I can hit configure. And now I'm going to configure this box. So it's pretty simple. Because it's a fan coil unit, it's really sealing cassette, but I'm going to have return air, a cooling component, and a heating component all contained in this box. And then this arrow is going to represent any outside air that's coming in. That's going to be mixed with return and then conditioned. So there's outside air coming in. First thing I'm going to do is specify how much outside air. I can do sum of spaces, percent, or custom. Sum of spaces is going to just sum up the required outdoor air for each space in this zone, and that's the number I'm looking for coming in at this box. So that's going to be good in this case, especially because it's kind of dedicated outside air going straight to the zone. I just want what I need. So sum of spaces. The cooling coil, I don't need to select a type. Direct expansion, I mean refrigeration, it's fine. What I really want to specify is my supply air temperature. 55 leaving. Now I'm going to be able to get proper CFMs for all of my spaces. Same with the heating. Specify 90 heating. Now I can get my heating CFMs for all these spaces. So I'm going to make sure that's defined. I'll actually go ahead and copy these inputs because all of my cassettes are going to look like that. In fact, all of my fan coil units in total are going to look like that. So I've gone ahead and copied it to those ones. I'm going to go ahead and copy it to these ones as well. Copy it to these ones. And then lastly, I'm going to copy it to these ones. Okay, so now all my zone units, aka terminal units, are defined. I've got supply air temperatures. I have some outside air going to that zone that's going to be accounted for at these coils at the outdoor conditions. So to account for this, the air coming in, remember I said that this diagram represents the air side delivery system. So even though I've listed it as VRF, I'm going to use this opportunity to allocate outside air going to my zones. So I'm actually going to set this up first as just outside air in, air leaving. This is basically a supply fan, an unconditioned supply fan. This is my delivery mechanism for outside air going to all my zones. I'll set sum of spaces such that now each zone is getting the sum of spaces outside air that's required for that zone coming from some sort of central delivery mechanism, which I'll call my supply fan. Even though this whole system is labeled as VRF, I do this because I want to be able to see for my system what the total load is for all the zones within it. And then here, I'm going to basically ignore my central cooling data for that system because it's really just configured as a outdoor air delivery mechanism. My cooling, because I've set up my zones in such a way, is actually going to be accounted for at the zone. So this right here, my cooling data, terminal cooling data, is going to show me my total load, my sensible load. It'll show me there's outdoor air coming in, only 30 CFM of it. There's 60 CFM of return air, and then my entering air condition to the coil is as such. My leaving air needs to be this, therefore I get a total and sensible load of this right here. So that's how I use this configuration in the summary to assess my loads for my equipment. Again, my central unit, VRF 411, this is the number I'm looking at here. I'm essentially ignoring this. And then with each zone, I know I have outside air coming into the zone, and it's being accounted for here in the psychrometrics, and then what that coil has to do to get to the leaving state of air. So, important thing to keep in mind as you configure your system. I'm now going to go and configure the rest of my central units. Okay, so I'm going to configure all of these like that. Outside air, sum of spaces, none of these other components are on. And just to confirm, I'm going to do a quick gut check to make sure they all got captured. Yep, sum of spaces. Yep. Let me check that one. Good, good, good. Let me just expand this just to do a quick gut check. Expand this. Check those. Okay. I believe we are good. Another way to check is if something hasn't been configured yet, you haven't touched it, you're going to see a dot there. So I'll be able to scroll through these lists as well to see what's been touched and what hasn't. So right now, I just have that, the AC units, the CU for my IT rooms and electrical rooms that haven't been configured yet. So I'll go ahead and do that. And again, this is the exact same setup. The unique thing about this though is in my electrical room and IT room, there's no outdoor air requirement. So this can be nada. I'm just gonna leave this blank because I don't need to account for that outside air delivery going to my zones here. So this will be blank. These, however, are going to be my fan coil units, return air, outside air method. I can leave it as sum of spaces because the sum of spaces is 0, so there's 0 CFM going in here. My cooling can be 50, heating 90. Now I've got some CFMs, and I can get some airflows for those rooms. And to quickly check, I can go to my summary. I can look at this. Here's my condensing unit. This is a great time to note if you have missed something as you're defining your spaces and you go to get your loads, it will tell you what's missing, which is very nice. So my electrical rooms and IT rooms, I have not defined my relative humidity. So let me go back to my space criteria, and indeed I have not. So I'll define that. Okay, now I'm captured. I'll go back to my summary, take another look at this, and there we go. I've got an overall total load for those 3 zones under this system. Again, this is a total breakdown, nothing going on really at that central unit in terms of air side analysis. So now when I go to each zone, I'll see correct 0 CFM of outdoor air coming in. This is really just a recirculation process, 690 CFM for this zone, recirculating, and this is my load on that coil based on all that information. So there we have it, and I'll check this one and this one. Same kind of scenario here. These are identical essentially because my main load is this miscellaneous. There's no people, there's very little lighting, These spaces are the same size, and I'm covered there. Okay, perfect. So everything's been configured. I can look at my summary here and go zone by zone, look at these total loads on the coil, and confirm everything looks good. Do a quick gut check here. One thing I look at when I'm assessing my zone loads is I'll compare the total coil load, which is it's a psychrometric process. It's actually looking at the design airflows going back here, and I will compare that to what my raw breakdown is, my total load here, and the sensible components are covered in the amount of supply CFM you need to supply. Any discrepancy between these is likely due to the way we're handling ventilation, and part of that comes from what the presumed indoor relative humidity is. So if I see something like here, the total load is equal to the sensible load. There's 5 people in there, and this is showing me 3,000 BTUs of ventilation. Maybe I suspect that there's going to be more relative humidity in this space due to more people. I can go and I can adjust my relative humidities. So I make that 55, and that is going to adjust my load in this space. And I can then check to see if it's a closer match to what the total is showing. And if it is close, that's a good indicator that you're designing for the right conditions at the coil. If it's a close match to what just the raw breakdown is. That said, the coil sizing is based on your design CFM. So if your calculated CFMs are lower than your design CFMs, that can also account for any discrepancy between just the raw breakdown and then what your coil sizing is. Now, speaking of CFMs, design CFMs, you'll notice I skipped over a step here, air balancing. After you configure your systems, you can go to this air balancing step, spaces. It'll take you back to the map, and now you can look at all your CFMs required for these spaces. And what we do is we automatically round up to the nearest 10 and consider that your design CFM. So if I scroll down on this space, I can see there's a load determined supply, there's an outside air required. My design CFMs are going to be rounded up to the nearest 10. And so I'm looking at 370 CFM for this office space, 180 for this one, 430 for this one, so on and so forth. This also gives you an opportunity to adjust these. So if you do not like these numbers, for whatever reason, you make an engineering judgment, you want to increase supply, or maybe you want to add exhaust, reduce return, transfer in, transfer out, you can override these. This is your chance to fine tune all these CFMs, and then those design CFMs will be reflected in your coil loads in your summary. So for instance, if I say, well, whatever, I got new information, for whatever reason, I need twice as much CFM in this space, I can go ahead and account for that here. And this is 101A office, which is part of zone AC 1-1, which is part of system VRF 11. So if I now go to my summary and go to that zone, you'll see my coil sizing here is based on my design CFM, 700. So that increases my coil load. It's no longer close to this 8,000 that is kind of calculated raw. It's assuming 360 CFM, which is the load determined amount. It's now based on my design, 700 CFM. So my coil has to handle that extra airflow, and I'm getting new numbers there. So this portion is reflective of your design, your actual design CFMs, whereas up here, this is just a breakdown of your load components. Now, I don't want to do that, so I'm going to go back to my space here and revert to the calculated value, like so. So that's a little bit on air balancing. This also becomes This also becomes a really nice printout. So great design tool. You can take this printout and start designing your dry side system using this printout. Now you have a map with all your airflows. You can start placing diffusers. In my case, I'll be placing a ceiling cassette unit in the center of all these spaces, so pretty straightforward. But I've got a map now of how much airflow I need for that, and paired nicely with my loads report I can print out, I'll be able to see the capacities required, the airflows that I need, and I can start designing. So that wraps up this tutorial, this walkthrough of doing really in-depth load calculations for what is a 52,000 square foot office building on multiple floors, multiple sheets per floor, something like probably close to 200 zones here. The last thing I'll do is, if I'm good with all these CFMs, everything looks good, I've gone through and I reviewed some of these loads numbers. I can go back and I can adjust numbers as needed, but if everything is really looking good, then I can go in to reports here in the bottom left, and I can now generate some reports. So the first report I'll generate is just my heating and cooling loads PDF. So let's call it heating and cooling loads PDF. Hey, why not? It'll timestamp it, and like I said, this is 200 zones. This PDF is going to give me every page of that load summary in PDF format, cooling on one page, heating on the next. So we're probably going to be looking at something like a 500-page PDF, just because there are so many different zones. Every space gets a sheet, so if you wanted to go space by space, you could look at that. Then every zone gets a sheet, and then every system gets a sheet. So that's like 200, 400 plus the system. Yeah, we're looking at close to, with heating and cooling, this is going to be a very large PDF. But hey, there you have it. After this loads, I can download it. And the second thing I'm going to print out is my heating and cooling loads CSV file, which is going to be really nice, because then I could grab my list of zones. I can cut it down to list of zones with all my cooling capacities and heating capacities required, and I can use that to start to build a schedule for my equipment. Now I already have that list. I don't have to retype it. I can start creating a schedule off of that. I'll show you what that looks like after I've downloaded this. Okay, so my report has generated. I'm now going to download that, and we'll open up this heating and cooling loads report. Yes. Okay, so as you can see, we are looking at a 974-page report. But hey, boom, generated just like that. And this thing is awesome. Remember I talked about that banner? Now it makes it look real nice. You got the banner right there, the name of your project. This is the heating and cooling loads report, timestamped, and this table of contents is extremely helpful. So it's already going to be hyperlinked for you. So instead of scrolling through and looking at every single page of your report as such, much more efficient to go to your table of contents, find the system or zone that you want to look at, and select it, and it'll take you right there. Here's my cooling sums at peak. Here's my terminal cooling data. Here are my checksums. Do a quick gut check. Hey, 465 square foot per ton, 0.95 CFM per square foot, looking pretty good. That's cooling. Next page is going to show me the heating, minimal heating for that zone. That's how I would go about that. And then from there, the next page is going to show me the spaces within that zone, which in my case, it's pretty much one space per zone for most of these. But there you have it. There's the full report. Go through this table of contents to find what you need. This is why it helps to be really meticulous with your naming, so it's easy to follow. Systems, zones, spaces, and check that out. So this is the PDF report. I'll show you a bit what the CSV report looks like. So I'm going to generate a new report, my heating and cooling loads CSV. And I'll let this generate as well. As soon as this loads, I'll pop this open and show you what that looks like. All right, beautiful. So heating and cooling loads CSV, let's download that. And it's going to break it out by spaces, systems, and zones. So let's start with systems. Open this up, and you're going to see all of my systems here and the data therein. So all of these columns represent different data points that you'll find in the loads report. also some breakdowns. So you'll be able to quickly assess how many people are in a system, what the total wall area is, total window area, roof, slab, all that good stuff. When it peaks, these are all peaking right around the same time, which is wonderful. And then I can go here. It'll show me total space sensible for the system, just like in the CSV or in the PDF report. I can keep going. In the next segment, it'll show me the total load, including the sensible and latent components. And then as I continue, it'll get into that central cooling data and then the checksums as well. So this is another way to review and assess your system sizing. After cooling, it's going to show you likewise for heating. But the one I really want for this application is my zones, because these zones represent the 200 plus ceiling cassettes that I'm going to be selecting. So I'll go ahead and open up my zones report, and now I've got this guy. So all of my zones here, scroll up, I've got 202 zones. Now I can create a schedule out of this. I can whittle down these columns to get exactly what I need for my equipment schedule.